So it turns out that the location and position of electrons has a huge effect on the way that a material behaves. And so we need to talk about uh, the state of different electrons. And so that's what quantum numbers is about. So this is a relatively quick little video, but gives you an introduction to those, to the 4 different quantum numbers. Uh, L is the angular momentum quantum number. Um, I'm not going to get too much in detail about some of these values, but we should know that they describe something physical about the electrons. This describes the angular momentum of an electron. So if we take that number L and put it in this equation here, where this is Planck's constant, then we actually get a value for its angular momentum. That is, how much rotational momentum does it have as it circles around the nucleus. For L equals 0, if we throw that in this equation, we see that big L, our angular momentum, is actually equal to 0. And that means it's not spinning around the nucleus. So we tend to think of things as, spinning, but again, that electron cloud model is probably a more accurate one. And so when L is equal to 0, there actually is no spinning. So that L is the angular momentum quantum number. And then real quickly, ML and MS also describe the movement of the electron. ML describes the axis of that orbit or that rotation around the nucleus. And that's in relation to the magnetic field. We're not going to get into that too much, but it basically describes how it's rotating or where that angular momentum exists. What's the axis of that angular momentum that we described when we describe L? That's why you get that little subscript L there. And then MS is our spin, and so that's the rotation of the electron around its own axis. In other words, it can either spin one way or the other, and we describe that as a spin up or as a spin down. So what